Hyundai 20L series with the Hyundai 2.4 liter engine and the E-Controls fuel system. And so the complaint is no acceleration, no throttle movement, no actuation of the throttle body. Sometimes the throttle body will randomly kick in, just like that. So when you scan the codes, you got accelerator pedal position, voltage is too low, and you have a signal plausibility fault, the accelerator pedal signal, the idle switch part of the circuit. All right, so we're gonna go to the pedal sensor and do some checks. So I'm just back probed into my accelerator signal circuit. The other lead of my meter is on the chassis ground of the machine. As you can see, static, I'm reading 634 millivolts. And if I actuate the accelerator, you can see it's gradually going up to about 3.5. And if I slowly go down, it'll return to there, to 630 millivolts. So that voltage isn't low. That's actually right around spec. However, if I switch my negative lead from chassis ground to the 5-volt return circuit at the ECM, where that's how it compares the signal, it uses a sensor ground or 5-volt return circuit to compare the signal circuit to that circuit. And as you can see, I'm reading 120 millivolts. So this is what the ECM is actually reading. And so if I actuate the accelerator, you can see it slowly climb up to maybe about a volt or 880 millivolts. And I'll slowly let it go and then return there. So it in fact is a low, the code is correct. It is a low voltage fault. It's just that you got to be careful how you're checking it. So like if you're using a chassis ground, the voltage may be good because chassis ground is okay. But the actual sensor ground or 5-volt return circuit may not be. And that is supplied by the ECM. Another check you could do too is the orange wire is the 5-volt reference. So right now I have my negative lead of my meter on the 5-volt return, which would be the negative side of that voltage regulator that is going to take the 12 volts and step it down to 5. And my other lead is actually on the positive side, the 5-volt side. And so the difference between those two, I only have 2.1 volts. But if I take my meter lead and I go to a known good ground on the block or on the chassis, you can see I'm reading 5 volts, right? However, when I start the engine, if you were to do this check first, you start the engine, and you can see that 5-volt reference is jumping all over the place. It's 5.1, it went up to 5.4. 5-volt references should be relatively stable with very little fluctuation. So the next check I did is I'm going to back probe the ECM supply grounds, because if you have a bad signal ground which is supplied by the ECM, the ECM supplies that negative. If that is faulty, you need to check the supply ground to the ECM. The same way if you had low voltage on the 5-volt reference side, you would want to check the voltage going into the ECM. You would also want to check the grounds too, but this is obviously our fault is on the ground side of the circuit. So I'm back probed into the ECM ground, and my other lead is just on the chassis ground. So right right? With the key off, if I just put this on ohms, you can see I'm reading 20 ohms, right? 20 ohms key off, or 15 ohms, I'm sorry, 15 ohms key off. That's a little high considering that this circuit is supposed to go directly to the chassis or directly back to battery negative. All right. And if I do voltage drop, if I do a ground to ground voltage drop, 1 millivolt is not a lot of voltage on the ground, right? But the key's off, there is no current flow right now. The minute I turn the key on, you can see it jumps up to about 350 millivolts, right? And then it goes back down to 50 millivolts, which is pretty acceptable. So what we're going to do is we're going to start the engine. You're going to see it spike up a little bit because of the current draw in the starter. But you see that it maintains 400 millivolts on the ground. Now, the ECM, now high voltage on the ground side of a circuit is usually hinged upon how much current the device can draw, right? So the ECM only draws maybe 3 amps at most. This is excessive. Yeah, I like to see this in the 50 millivolt, 100 millivolt range and be relatively steady, right? And so obviously we still got our fault, no acceleration. So what I'm going to do to prove it out is I'm going to give that ECM the ground it needs so that it can provide the correct 5 volts to the sensors, because that's not the only sensor that utilizes that 5 volt reference and 5 volt return circuit. All right. Okay, so all I did was I took my back probe and I jumped it right to battery negative, and right now we're looking at a relatively steady 5 volt reference. It's not 5.3. It's jumping around a little bit because of the connection at the ECM that I have. But so got my ECM supply grounds going directly to battery negative. Engine's running. Back probed on my signal circuit. As you can notice, it's nice and stable. Also, just to show, check engine light is out, and we'll just scan for the codes again. The ECU has no fault. And we'll go to monitoring just to look at our foot pedal position. So you deselect all of these and just select percentage. And should be accelerator position 1. And so you can see right here, it's at 0%. And when I accelerate, now I'm going to show you something a little unique about the diesel laptops, especially when you're in the monitoring, when you're looking at the live data. Sometimes the data PID will say NA because there is a problem with that input. And also too, a lot of times with the data selection, they give you a lot of information that the machine may not necessarily have, and those are also marked NA. So you got to be careful when you're looking at these inputs, because watch when I recreate the fault, you're going to see this. You're going to see this go from 0 to NA. So I just took away the ground, and you see it go to NA percentage, not available. All right, so like, you got to be careful, because that can trick you to make you think that, oh, this data PID probably isn't supported, right? It may not be, but also it may also be that there is an actual problem.